Okay, well, thanks for coming back for part two. This was originally going to be a BOF, but then I started thinking about how to introduce it and ended up with a talk. But then we ran out of slots, so this is both a talk and then hopefully I'll end sooner than half past. This is basically going to be thinking about the question of where is my module BMI? Why am I looking inside a Coke can? And I think it was Richard Smith who said this, that there's a temptation to put all the smarts in the compiler, and the compiler should go away and find the module and BMI and stuff, and then you turn the compiler into a build system, and yeah, that's not very pleasant. But the other thing is that you're all smart people, and think about this, you're going to come up with a bunch of ideas that I may or may not have tried. So let's just, I'll explain stuff that I tried and didn't seem to work well. And yeah, so first things, modules are not headers. They're different to headers because they generate this on-the-side artifact. Then I got some experiments that I did, and then I had to rethink about exactly what problem am I trying to solve. And then I had an idea that seemed to have legs. And then we can go wild. So here's a similar picture to that I showed in the first talk, but this is with headers. With headers, we have a foo.h and bits of foolib, and we compile foolib and build a library, and then we distribute or use in our user code. We end up using this foo.h and this library here, and none of these bits. Okay? And we understand how this all works because we have a file system, and we our magic box is the file system. We refer to these things by name, that's the file name, and we have this on the side hash include path that knows which bits of the file system to look in. These compilers may be different. The user may be using a different compiler to the one that I built the library with. Maybe, or it may be the same, right? And it still works in headerland. But then when we start to think about modules, we get this picture. Here's our magic box, what we still need. But we have a question of what bits do we give to the user? Do we deliver to the user this binary module interface and they never see the source file for the interface unit? Or do we give them the interface unit and they reconstruct the BMI using their compiler? They reconstruct it the one time they need to build it, and then they don't need to rebuild it anymore, even though they're changing their code. Yeah. And this is like the first question you have. Somebody asked me in the definition, which do you do? So the BMIs are like generated headers. They're generated during the compilation process. But if we distribute them, we're locking what they look like in and making it have to be the same across different compilers and different versions of the same compiler, and this is all horrible. Because not only do we have to decide what the standard is, we have to decide, all the compiler vendors have to either agree or lock everybody into their own compiler and version and stuff, and this is just ugh. But the other thing is, if you think about it, if I'm not giving my user the interface, how on earth are they going to do source debugging without getting this thing anyway? And we probably want to give them these bits as well, because otherwise similar problems. So we're just going to distribute this thing here anyway, so we may as well take advantage of that distribution and do this scheme here where we don't distribute the BMI, but it gets reconstructed as needed by any way you need it. Because you're probably going to have bake-in bits of compiler options into that anyway, like, for instance, whether you're doing 32 or 64-bit target on the same architecture or whatever. So all you're doing here is locking down things much more tightly than you end up locking down stuff here, because these just need to be AVI compatible. Here you need to be slightly more the same. Oh, where did we go? Oh, I've lost the slide. Oh, crap. Oh, no, I haven't. Right, I just got confused. Yeah, so they're like generated headers. They're from sources that we actually have. It may be there, but the answer is yeah, you have the source to the thing that the BMI is built from. And they're different across different versions of the compiler and different compilers. So let's not lock them down. So first thought is, well, why don't I, header files have a search path? Why don't I use a search path? So I implemented fmodule include and had a search path there. And it looked down the search path to look for a BMI that matched the module name that you'd given. And I've just skipped a step there, but I'll just get onto it in the next bullet point. And, and it goes, well, how do I recreate these? I end up with problems of how do I build these things, because they have to be built on demand somewhere in this space, because that's what I just decided to do. So they're not like vendor-delivered header files that sit in user include. That's not going to really work. And I ended up having, and to have this work, you end up having to lock the file name in some way to the module name, or have some mapping from module name to file name of BMI, which I did. And that's new module system, suffix I chose for reasons. And dot is not a very friendly name to have in the middle of a file, so I changed it to a dash. But again, I'm forcing stuff onto users here, and this seems unfriendly. And I had that. And then what happens if this BMI cannot be found on this search path? Well, then I implemented this, which was fmodule wrapper equals, and it was a program that the compiler, CC1+ would end up forking and execing a program to go build the BMI in a way that the compiler didn't care about, but just said, you go build it. And my default implementation was a bash script that looked in environment variables in a similar kind of way to the LTO offloading stuff works. But it's like, I've just invented a bunch of stuff, locked things down, and it's not very flexible. And what if the next user this doesn't work really well for the next user? So, yeah. And indeed, the next user said, yeah, none of this really works for me, can I have something different? So we end up inventing a new scheme for every new user, and no, let's not do that. Let's find a better way. So then I thought, well, what problem am I actually trying to solve here via example? So here's the simplest case I could think of. This is what any user of modules is going to do on the first time they get a modules compiler. They're going to write a module, and they're going to try and use it. And they're going to write it on the command line, invoke the compiler on the command line. And this better work, because if this doesn't work and requires you to make, write a make file and some configuration stuff, this is too hard. Header files were painful, but at least they worked without me having to write other stuff. So these things did work with the schemes that I just showed on the previous slide, but let's not lose sight of having these things work. Okay, that in this case, it generates a BMI for hello, and this thing slurps in the BMI for hello, and off we go. Slightly more complicated case, when you get a bit further, you're going to get a build system, and we're going to think about make. Some kind of serial build invoking something that looks like make. Well, we have the -mm flag that squirts out dependencies of header files during the compilation of a file. And this works because the header files are already in existence. They're not generated during compilation, so we can find them on the fly on the first time round we build this. Because the first time round we know we're going to build this because there's not a foo.o, so we know we have to build it. So let's go build it. It'll find all the header files for us. So the next time we invoke make, we can go and check the timestamps on all the things we found the first time around, and if anything's changed, do the regular make things, and have some kind of include of all the obj stuff there. But this doesn't work with modules because the modules are generated during the compilation, and you can't get further without, so you have to have some kind of, this doesn't work. And I remember last year I asked Jacob in the room, anyway, he knew how the GNU Fortran module thing worked, and he said the way he gets GNU Fortran modules to work is he just invokes make sufficiently many times for it to succeed. Yeah, if you've got tens of thousands of files, that is not a suitable algorithm. So you're going to have some kind of make depend where you invoke the compiler in a pre-processing mode and then strip out the import lines and figure out what they point to. So you have to format your code a bit. And apparently the cool kids are using Python these days, but so I should have used that. But anyway, you do something like that. That might kind of work. It would be good if we could make something like this work without the compiler having to know too much about the contents of this script here. So then I thought about, well, oh yeah, there we go. Oh right, yes, we're still pre-processing the thing twice. We pre-process it here when we find the dependencies, and we pre-process it here when we actually compile it, and we have to re-pre-process it every time in case the dependencies have changed. Well, that's so, but with the Atom thing, all the imports are at the beginning in the preamble, so we could have a preamble mode that just stops pre-processing once you've reached the end of the preamble, which I have. So at least you're not pre-processing the whole thing twice. You're just pre-processing the preamble type. So okay, that might be a suitable way of doing things. Then I thought about, well, what if you've got a distributed build? When we got things on different computers that we have to get across. So let's say, assume we can compute the import graph up front before we invoke anything, or we do that make depend step effectively. And then we have to copy the BMIs across from where they've been built to where they're going to next be used. Okay, then, well, that discovers then these BMIs must be copyable. We don't want to stick any absolute paths in them relative that's concerning where they've been built. And hooray, they are, in my particular case. I've made that so. Clanger's made it so as well, for much the same reason that we need to copy these things around within a build. Or have that. But we're still pre-processing this stuff twice, effectively, so that's a bit unfortunate. Yeah. And the problem here is that Atom legacy headers export macros, and those macros could affect what you later hash include, and that changes your dependencies. They can't, and they could affect. No, they can't affect what you import in the Atom proposal. In the merge proposal, they can actually end up affecting imports because the merge proposal doesn't require a preamble thing. For reasons that turn out to be, yeah, that kind of needs to work. Anyway, so we still have kind of a problem here. So then I thought about what's an even more general case of lazy graph. Let's assume the build system doesn't know the graph from the get-go. It just knows I've got to build this program, and this program is built from these object files, which are built from these source files. But it doesn't know anything more than that. So we want to discover the import graph during the build. Right, which is where I was starting from with the F module mapper wrapper kind of thing that I had there. Well, and I found a dependency that I didn't know about. I better go build it, otherwise I can't continue. So I see the import of something, and then I call some piece of my compilation system that says I need foo's BMI. And I wait for an answer and then continue. All right? Okay, that would be a nice way of making this thing work, but it's still, unfortunately, serial because I have this this question asked every time I see an import or see a new import. But again, Atom preamble to the rescue. And we do all the imports right at the beginning before we've actually parsed anything else other than preprocessor directives and stuff. There's no other decals there. And none of these imports affect each other because they don't see, the legacy ones don't see hash defines I've already defined, for instance. So that means I can actually reorder these things in any way. That's an important property of all the imports you do. I can reorder my imports without breaking my code. That's a desirable property. So I could batch all the imports to the end of the preamble. When I get to the end of the preamble, I then go, oh, right, at this point I need to actually have all the imports done. So I could ask ask this oracle for all three things that I've imported, wait for it to build all three things in a parallel manner or whatever, and then continue. Right? And it was this case that I was thinking about talking with the Clang developers. We were having a meeting about exactly how this is. Can we fix this problem without baking more stuff into the compiler than we need? And we didn't phrase the question this way. I phrased the question this way that makes the answer obvious, but we didn't ask it ourselves this way. You know, so it was only when I was later on, back in the hotel, going, oh, hang on, I ask an oracle, oh, that's a remote procedure call. Oh, hang on, that's a client-server interface. I know how to write client-server interfaces. Let's go do it. So, you know, 2 hours later, I already knew how to spawn a program because of that module wrapper thing working. So I changed it to spawn ncat, got ncat to go and talk to another terminal and typed at it as the server, and it would ask the question saying I need a BMI, and I would just type the answer in, and it was a 2-hour hack that worked. It was a horrible protocol at that point, but that's not, it's proof of concept. So this then got extended, and this is what I have in the compiler that I've got. What it's trying to be is a way of the compiler providing a hook to the build system where they can communicate during compilations. And everybody said, oh, you put a compile server there. No, it's not a compile server. All it is the compiler asking questions of a thing that has more knowledge, more global knowledge of the environment than the compiler has. Okay, and I have a default, so the simple cases just work. And by the simple case, I mean the very first case that I showed you. It may be that this default is not what we want to end up with, but at the moment it's sufficient. Yeah, right. It happens to be a human-readable text-based query response language, and I can batch it to reduce round trips, so it ends up being a handshake and then a request for all the imports, and then it gets all the answers back when the build server has either built them or already knew where they were, and you're done. And I kind of tweak this protocol when I find more stuff that I need to do. Right, yeah, and it's in the compiler at the moment. You can invoke it by either talking to this case here is just a file of tuples per line of module name, file name, pairs, and it just reads that in at the beginning. Disadvantage here is that it's reading this file in every compilation. This file may end up being huge, but you only need a few instances of it, or a few entries from it. So that's undesirable. That may be not what you want. But the build2 system that some guy, what's his name, Boris, is implementing uses this scheme. I can talk to a Unix socket with this equals happens to be what ls tells you when you look at ls, a Unix socket, so there you go. IPv6 socket it'll talk to, right? If you've got IPv4, yeah, you just need to do something different, get with the program and modern age and stuff, or use ncat. Or spawn a program, and if I spawn a program, they'll just talk stood in, stood out to it. So if you want something else, you can spawn there. So you could stick your knowledge inside whatever program you write here, or you could put it in these other things here and have one instance of them. Yeah, and the default happens to be a program that I wrote that's there that understands this protocol and implements the default I described at the very beginning, and you can actually run this thing as a standalone server and get it to all your compilations to talk to the single instance of it if you feel like it. I imagine this will be extended. Right, yeah, so this is kind of how I currently envisioning it working. What I've got here is something that provides a mechanism without any policy. So the compiler is now the compiler itself is completely agnostic about where these BMIs are, how they're built, how I find a BMI given a module name. The compiler does not know, doesn't need to know, it uses this protocol to ask a thing that provides that policy. So that means it's not my problem anymore and I don't care. And yeah, so anyway, yeah, the build system creates one of these things that listens on some particular port, spawns all its compile jobs telling them to go talk to that particular port, distinguishes these different compile jobs by giving each one a different cookie that then gives back in the handshake so it knows which is which. I'm not trying to be cryptographically strong here. If you've opened your port up to the world and your build system, yeah, you're an idiot. Don't do that. So clearly there are denial of service attacks here, but if you're being denial of service by your own organization, you've got bigger problems. Yeah, and it builds the import graph as requests come in, and it can spawn other compile jobs. Or the only modification to the build system further than this stuff, it needs to kind of discount compile jobs that are waiting for a BMI as actual active jobs, otherwise you could get deadlocked by saying, yeah, I've spawned all 15 processes, I'm allowed to spawn, I've got no more spare processes. And talking to people that do big build systems, they think this is entirely tractable and looks not stupid.
The BMIs appear on the system by means of running a compiler on that system, that they are not distributed by a software vendor in the BMI shape.
Yeah, they could be, but back in the earlier slide of the picture, I went through that saying these BMIs are fairly tightly compiler specific and and probably option specific, compile option specific. So having them locked to what the vendor gives you means that you can only probably compile in that particular mode, and that may not be what you want to do. You could, there's nothing in this that stops what you've just described happening. All that would happen is that the compiler would go, the build system would go, yeah, it's over there, because it's where the vendor put it. And maybe that's the default that you want to happen. I don't know, right? Like I say, this is not mandating a particular policy on you. What you've described, I suspect, is actually, it initially looks like the way to go, but I think it turned out to have difficulties. Because we're trying to match it. We naturally try and, oh, I'm going to model this stuff on stuff I already know, which is header files. And these are sufficiently different from header files to have difficulties trying to do that all the time. I think that was a question.
Couldn't you build BMIs in a way such that the full source is recoverable, and then?
Yeah. Oh, right. Yes. So, in terms of what I have implemented, the answer, well, actually, yes, because if you notice on that README, I show what source file it was built from. There's nothing in the actual proposal that requires binary module interfaces to be binary module interface. You could just copy the source and recompile it on every import. And maybe you want to do something like that for static analysis tools, right? For improving your build speed, you do not want to have to repass them on every import, because that's expensive.
No, what I wanted to suggest is require the BMI to be able to reproduce the source code from the binary, such that when you compile with a compiler that is not that BMI version, it can always try to go back, reform the source code, and make its own BMI.
You certainly could do that. That's next line. If you wanted that to work across compiler versions, they would all the BMIs would have to have some kind of similar packaging way so they could be introspected by other compilers. That's certainly a possibility, yeah. Like again, maybe the build system goes and looks at the BMI and goes, oh, hang on, I don't actually understand it for this compiler. Because part of in the protocol, the handshake thing was actually A, version number, but B, yeah, I'm this compiler. So it could, what you sound like, yeah, what you suggest sounds completely tractable in this, yeah.
So a few times, Nathan, you've mentioned that the source distributed header export declarations might be compiled with different options. I'm wondering, how does that stack up with the binary of the library that you've distributed, the actual implementation?
Right.
It's not obvious to me that you can legitimately recompile the exports with the different options from the ones that were used to export the actual implementation.
Yes. To answer that question, maybe you have the source of the library and you recompile the library yourself, in which case you have complete freedom. Maybe that the options that you do for building the BMI are some subset of the whole options of the compiler such that they remain compatible with the object files that you have been given. Yeah? Because I don't know offhand whether if I turn the optimizer knob on, I get different ASTs or not. Now clearly, and whether that is actually, if I build a BMI with the optimizer at 03 and then import it into a thing at 01, I have no idea if that actually works. Might work, might get lucky, it might work by accident, it might work by design, but you know, I'm not going to say it'll definitely work. Whereas you want that kind of freedom. So it seems the safest thing is that, yeah, BMI should probably be regeneratable in some way.
No, I mean, that makes sense from the point of view of interoperability between compilers. It was just the issue about whether you could validly change options without breaking ABI, for example.
Yeah,
I had a very similar question about the compiler options. I mean, there clearly are a number of compiler options that don't impact the ABI or API warning options come to mind. There also are optimization options that could, and then some that certainly do, like signchar or the data model options, 32 and 64. So have you thought about not you necessarily doing the work, but us as a community partitioning the options such that the compiler has the ability to decide reliably whether or not to recompile?
It would be very nice if they were separated that way. What I do at the moment is I strip out a few options that I know don't, and in particular some of the module generation ones where you definitely want to have, you know, whether you turned on dumping or whatever, that is irrelevant. But I'm quite paranoid about it, so that the thing that's embedded in the configuration is pretty much all the options modulo about half a dozen that I know are safe. And that is clearly paranoid and more conservative than you need to be. But it's also, I know it's safe.
I have one question. I think I understood how the compiler can query your Oracle for the data that it needs. But how is it actually, how is the Oracle supposed to know that by compiling foo.cc it will generate the bar.msi?
Yeah.
That is not clear.
Yes, excellent question that I've punted on here, because I've now made it something. No, the tooling group in the standardizer committee is actively thinking about this problem and how do I do that? Because the closest we have at the moment that I'm aware of is things like Clang modules, which is the legacy header thing equivalent of that's in Clang at the moment. And they have these on this side metadata stuff that is human constructed, that Clang reads in, and it's its own format. You know, probably looks something like JSON. I don't know. But yeah, excellent question. I do not have an answer.
Going back to which options are important thing, don't we already have that from precompiled headers?
Maybe. I'm not sure. I probably spent a little while hunting around for it and then just,
Well, I know that that for libstd C++, we build PCHs with different sets of options.
Right. Yeah, I don't know the answer to that, Jason. But yeah, it's probably worth looking again. But what in the priority list of things, this is now lower down because I've made it safe. Before it was just a fix me saying, fix me, this should be made safer.
Have you thought of integrating this protocol or making it compatible with the GNU Make job server protocol?
Right. Yeah, I looked at GNU Make and I...
What I was thinking of feeding dependencies back to Make and have it build them and stuff like that.
Yeah, no, I don't know. As far as my understanding of Make, and I haven't looked at its source code, is its job server protocol is basically allowing subjobs to know when it's safe for them to spawn a subjob of themselves. So it's basically it is just job control. It's not a way of telling invoking Make, oh, by the way, I found another dependency you didn't know about, please fix it for me. It would be really great if Make could have that capability of being able to inject during its processing, oh, there's another dependency. But I have no idea how complex that might be to implement in the current source base. But it is that kind of thing. Sorry? Yes, it would have to know things that are blocked so that it could respawn. It would not hit its -J limit stupidly, but it's also changing its dependency graph. And I don't. I've always thought it computes that before it starts anything, and this is modifying it during the computation. And I have no, I don't know, but yeah, it would be nice if that sort of worked or did something.
This may be an insane idea or feature creep or anything. It struck me that this is kind of similar to a packaging system, where could one of the things that the Oracle does be go and fetch a tarball from a URL?
Yes, because it could do that. I'm trying to remember what language it was talking about. Oh, it was. I don't know if it was Perl or something that had during my build I'm going to randomly slurp data from this server over here and hope I trust that person.
Well, a lot of the language ecosystems, Perl, Python, Ruby, Rust, they all have their repository of modules, and I think there is one for is it Conan in the C++ world? I'm not sure. Okay. Boost.
That was, funnily enough, packaging systems was another thing, another evening boff at one of the recent C++ meetings, and it was like, we don't really know how this, what the right way of doing this is. There are too many options. There's no obvious winner, and whatever happens, some subset of people are going to be upset because it's not their favorite, or particularly not the one they use. So, I don't know.
I have a comment about packaging systems. When you design a packaging system, assume a world where not everyone has access to the internet.
Yeah.
And that should be the first thought.
Yeah, good point.
The nice thing about this is that all those questions become part of the Oracle, and you can have different Oracles on different machines. You can have an Oracle that gives you locally built stuff or pre-existing stuff, or because there was a proposal a few years ago for allowing hash import with a URL, which would then download a package and build it as part of the pre-processor step. I think the Blizzard guys, the game engine company, they proposed this to WG21, and I read the thing. I was just like, I think I wrote a screed of like why this must never happen, because it was talking about basically putting curl into the compiler during the preprocessor step, which would then stop what it was doing and build a new thing, and then put those headers. I was like, this is Make. That belongs in the build system, not in the preprocessor.
But I mean, there's nothing wrong with a vendor extension understanding URLs as the thing you put after hash include.
Yeah. But put it outside the compiler in some Oracle, and then people can have arbitrarily many different types of Oracle that can do clever things.
Indeed, I implemented it as a protocol because I happened to have a way of spawning a sub-process, and then I thought about it a little bit further. I thought, should I do this as a GCC plugin? And the answer was no, for two reasons. One, I would then have to learn all about how to write a GCC plugin, and my brain was full. But the other reason was that if I did that, then everybody would have to write a GCC plugin, and a Clang plugin, and a Microsoft plugin, and an EDG plugin, and to do exactly the same job. Whereas it'd be really nice if I can persuade people, and I'm working on Clang, this is the interface to use, or something that looks very much like this. Let's go that way, so that build systems only have to write one thing, and compilers only have to write one thing, and it's all plug-in compatible.
I think an example of where Rust has its cargo system, but I think they have the advantage that it's kind of an entirely clean, green field of without all the legacy to worry about. But and they can. It is the established default. It's like you do cargo build or whatever it is, and it will fetch all the dependencies, build them, and so on and so forth. But it's because there isn't how many decades of legacy to build on top of.
Yeah, I think it may have been Rust cargo thing that I was reading about, downloading stuff automatically.
And a single compiler to implement it in. Yes. You know, with C++, we've got not as many as there are C compilers, but there are a number of implementations. And if your source code starts putting in URLs, you're like, well, you can't compile that unless you've got the latest version of every compiler that supports this, because GCC 9 is not going to have that feature. And yeah.
URLs and hashes.
Yeah, again, C++ is distributed, and there is no trusted authority. There's no single compiler. There's no single implementation.
I realised I had one more case that's actually quite interesting to look at, because it turns out to be, I think, probably more complicated. And when I import a legacy header, it requires some human to have gone, yeah, that's a legacy header. We know how to build it, right? But when I'm compiling this legacy header as a header file, as a legacy module, it's just going to be regular hash includes inside it. And it may inside it have a hash include other header.h, right? Do I textually include that thing as a regular header, or is the other header itself a modularizable header? And should I actually have thought of this as import other header that I then have previously built? Because that would be better to do it that way, as I reduce my merging problem with finding whatever this thing declares in two different places. So again, we have a question to the oracle. I'm about to, from the preprocessor, saying I'm about to hash include something. Should I turn it into import something? And the oracle can turn and come back and say, yes, you should, or no, you shouldn't. You should have it textually included. And it could come back with saying, oh, it's textually included, and this is where it is, so I then don't have to do the search path thing. Or I should import it as maybe as a different name, because I happen to know some magic or whatever. And that's in there. And this opens the door across compilations on a big system of actually dealing with the include locations and caching them inside the build server, rather than each compilation having to find it out for itself, which turns out to be quite expensive doing lots of directory searches. So that was an idea that I hadn't thought about. Somebody suggested that to me when they saw this and said, yeah, we could do that maybe. Anyway, so this is also in the compiler at the moment. The preprocessor will go talk to the mapper and go on the hash include line, and I inject, instead of doing the hash include, inject some tokens into the token stream, which was kind of fun getting that working, but that's there. Right. Now, that was all that. Now, yeah, we've got like 15 minutes to solve the problem.
So I was hoping to ask the same question I asked at the end of the last talk about how much more difficult do modules make debugging, and in particular, I didn't mean debugging runtime problems, but debugging compile time problems. Say, from a point of view of a C++ developer, you get a bug report, or you're trying to create a bug report with an internal compiler error.
Right.
And the ideal in this case is
that problem.
Say, yes, translation unit.
That is probably going to make Jason and my lives much harder, because we can't say just send us a preprocessed source, because there, particularly with the legacy, without the legacy header stuff, we can generate the preprocessed source, but you need to generate the preprocessed source of the thing that's died and all the modules that it transitively imported, so that we can then reconstruct everything. Right? It's even worse with the legacy headers, because they export macros, and you can't actually generate the well, this is the bit I haven't implemented yet, is the getting preprocessed source out of the thing which has a legacy import, because I have to do some pre-processing. I see the import legacy module. I have to emit that as preprocessed source, but I actually have to then go and do the import to get the macros that it would make visible before I then continue on with the pre-processing. Now, that's going to be exciting to implement. I haven't got there, and yeah, I'll let you interrupt, Jason, because I know there was a question over there, but yeah.
To make our lives easier, I wonder about kind of defining a magic comment format into which you could dump a BMI to go with the beginning of your pre-processed source code. To just represent all the imported BMIs and then the translation unit source.
Yeah, that's a good idea. Then of course, but we still have to get the right version of the compiler that understood that BMI model. And at the moment we don't have that stability to do that. But yeah, I think we may well end up with having some way of, -f generate bug report, and it does the right things, whatever we decide those to be. Yeah. Yeah. Open question.
I wanted to ask, what BMI format do you use right now? Like, how does it look?
So that was that ELF file from the. Were you at the earlier talk?
Yes, you were. Yes, I was.
Yeah, so that's the ELF section header stuff. The contents of those ELF sections is fairly opaque, and I don't guarantee its stability at all at the moment. Depending on which bit you're looking at, it's going to be, mostly it's down to variable length encoded numbers and
character counted strings. But precisely what it looks like there is, go read the source code to understand what it looks like.
And the other thing is just the debuggability thing. I think if you have BMIs that can regenerate their own source code, and especially if you can merge BMIs together, and you can just have one big debug bundle of your program and send that up to your
that sounds like a useful direction to go about that. There have been a number of suggestions on some kind of common BMI format, but I think that's going to be hard to achieve because it's a lot of work for any random compiler to go and generate code. And some bits of the C++ language aren't implementation defined. So implementation may be different classes and not be compatible, mixed with each other. You're going to get some weird mixture of behaviors. So I don't know how practical that kind of thing would be.
Nothing that's just empty. There's also work on what's the word for when you try to find hierarchical functions of introspection. What are there any movements for the introspection and the module people to work together?
I'm aware of introspection. And there's bits that have gone based on the template instantiation type model, but there's some far more interesting ways of that. As I doubt if any of that will come in model. Essentially, in the BMI thing, you have to represent special stuff, would have already represented the same stuff that generated if you read the file of the source code. That's exactly what you're pressing. So that's probably really restraining the introspection requirement. So I would be upset if it did.
So I'm going to ask a question about implementation. Suppose you what can I do on a different platform? And that platform doesn't happen to be based on output generally. Is the choice that you made completely opaque to me, or do I then need to map?
No, it's completely opaque to you because writing the ELF real life that I need in my 200 line code. And I built this stuff. My server choice is actually 64 minutes. I've built it on ARM 64 minutes, PowerPC 11, 64 minutes, and I've built it on the AI PowerPC. AI PowerPC, I had to add some bits in yours will not have to run tests. AAX failed test because I was a genuine bug that I fixed. AAX is my go-to. Now I know how to build there. It's my go-to choice of weird system.
Okay, so basically the fact that it's just a binary job as far as any platform is concerned.
Yes, indeed it is. The advantage is that I can really have to look at it.
Yeah, and you can do a reload of other platforms.
Yeah. Then I have to use more system calls to bring it up. I mean, previous was no far behind. Yeah, and I can index it by numbers. And give you, if you give you a file, I can try to, somebody.
Just to return to the common BMI format, one of the biggest mistakes that was made in the Fortran world was not to the common format of the equivalent module files. And in fact, none of the various module files interoperable at all. And this is one of the most frequent complaints of compiler users that this is not the case.
I think our common format is source code.
Yeah, yes, I've thought about this. And people come, the common format to give you a bit of program, Station says, is source code. What we have. Why are we trying to do something better than that, that's as general as that?
So that's the current implementation, which says improve or deteriorate the quality of error messages sent with code. So if an implementation of a library fails to satisfy some constraint that's not properly expressed in its interface, currently you get reason error messages pointing to the
I think the solution to that is actually context. And this is that problem. The traceback looks a little bit different, because instead of all saying predefined, so it's in modules, as long as you've got the same line number, it's like you'll get the same stuff. The partial instantiation thing is going to be interesting, because at the moment, templates, when you do the lookup for inside the template, when you need to do lookup, you do it at the point of definition of the template, and you do it at the point of instantiation of the template. Now, in a passing through world, the point of definition of the template cannot see more stuff than the point of instantiation. Right? That is no longer true in the module world, and then there arguments about this passive instantiation stuff, because there can be things that can be seen on the way instantiated, but neither place. So you're only doing more lookups there, so you may end up with more choices and therefore more confusion. But whether that's significantly different complexity than what we currently have, I'm not sure.
The error does mention the assembly line code.
Yeah, that will be exactly the same. Correct, yes, because I'm preserving my own. I mean, I won't be preserving it in all cases at the moment, mainly because I have not implemented it. There's no reason why, location as precise as it currently is. Right, I have something else to say, which is that C++ 20 has two areas, has a bunch of things that are probably good. Another one is code. Facebook has just contacted me and Sando to go implement that in VCC. Yeah. So we should have code to compare some type of not too distant future, not GCC 9, but probably behind.